Okay, hi everyone. We're GOSTEM and we're going to be presenting on engineering innovations and shaping the future of medicine.
Sorry. So Scientolic is a youth-run nonprofit that aims to introduce scientific concepts in a manner that is fun and comprehensible to teens. We serve as a free resource for students to learn about science topics. We strive for our teenage readers and contributors to be critical thinkers and promote thought-provoking conversations. We provide various opportunities for students around the world to practice English as their second language, and we provide volunteer and leadership opportunities to those who want to help others. Yeah.
So we are GOSTEM. We are an organization that helps middle school students explore different STEM opportunities through webinars, competitions, and events. And I'm Nishita, one of the co-founders.
And I'm Porna, the other co-founder.
And Porna.
Yeah. We can just skip that.
Okay, so biomedical engineering is a multidisciplinary field that applies engineering principles and techniques to solve problems in biology and medicine. This field, also formerly known as biomedical engineering, includes several specialized areas. There's medical imaging, which involves technologies like MRI and CT scans to visualize the human body, biomechanics, which focuses on the movements and mechanisms of biological systems, bioinstrumentation, the development of devices that monitor and treat medical conditions, biomedical computing, which uses computational tools to analyze biological data, and genetic engineering and biotechnology, where genetic material is manipulated for medical advancements. So what does a biomedical engineer do? Biomedical engineers are really at the forefront of medical innovation. They design and analyze a wide range of products and technologies that improve human health. These include prosthetics and braces that help people regain mobility, surgical devices that enhance the precision of operations, medical models used for planning complex surgeries, dental devices that improve oral health, as well as developing new medicines and treatments. They even work at the cellular level, designing and manipulating cells and tissues to treat diseases. A prominent area within biomedical engineering is 3D printing, which is revolutionizing how these devices are created. So kind of shifting gears, what is a manufacturing engineer? Manufacturing engineers play a really important role in the production process. They design, implement, and optimize manufacturing processes to improve efficiency, quality, and cost effectiveness. Their work involves developing and refining production processes, and they are constantly focused on continuous improvement by analyzing and enhancing existing processes to make production as smooth and efficient as possible. So let's look through the eyes of a manufacturing engineer.
The path through manufacturing is incredible. Manufacturing is not just sitting behind a machine and stamping out parts. The Certified Production Technician credential is an excellent tool for anybody wanting to get into manufacturing or already in manufacturing. It was actually designed through the Manufacturing Skills Standards Council out of Alexandria, Virginia, to be a tool for somebody that has worked in manufacturing but did not get a degree. The four main aspects of it are safety, quality and measurement, maintenance awareness, and manufacturing processes and procedures. People that learn those four aspects of manufacturing will do well. The path I've taken is like hopscotch. I've done a little bit of everything, but anytime something's come up that's an opportunity, I've tried to take it. And once I got my master's degree after 12 years of night school, I stuck with it. My career path was not exactly what I thought it would be when I started, but up until this day, it's where I like being. I've been paid well for the work I've done. I remember starting at McDonnell Douglas in 1982 at $7.25 an hour. I've been able to raise a family buy a home, do the things that I've wanted to do. I've traveled. I've had a lot of good opportunities. Yeah, the CPT is a good way to get back into the workforce, especially here in this area, Brevard County. We have over 500 manufacturing companies right here. The CPT is a good way to get into a lot of these companies. So in that 10 weeks, they gained a lot of knowledge, and that knowledge is credibility through your employer. You know, it shows that you really, you're involved, you're engaged, you want to have that job. So I've got friends that we all started out together after the military. Some of them are quality inspectors now, some are engineers, some stayed technicians, others went into safety. There's all kind of avenues that you can take once you understand the basis of manufacturing, the manufacturing principles and processes. The opportunities are endless.
This video really showed how what an impact manufacturing engineers make.
So now we're going to talk about the different types of manufacturing there is. So the first one is additive manufacturing, also known as 3D printing, and this is the method that involves creating objects by adding material layer by layer, and it's highly customizable and is often used for prototyping. And for example, we can create customized medical implants with additive manufacturing. The second type of manufacturing there is subtractive. And in contrast to additive, this is just where we remove materials from a solid block or workpiece to create the desired shape or product. This usually involves cutting, milling, drilling, or grinding to subtract material from a larger piece until we get the final product. And so an example of this could be machining parts from metal blocks using computer numerical control machines, where precise cuts and shaping are made to form complex components for industries like automotive or aerospace. The third type of manufacturing is forming. And forming is a process that involves shaping materials, usually metals, by applying force or pressure to cause plastic deformation without adding or removing materials. So it's unlike additive or subtractive. And so the material is just reshaped by altering its geometry, but it still maintains its volume and mass. And the last type of manufacturing is casting. And casting is a manufacturing process where liquid material is poured into a mold, like this metal liquid right here. It's poured into a mold that contains a hollow cavity of the desired shape, and then it's allowed to solidify. And once the material solidifies, the part is taken out of the mold and it undergoes further processing to be used as the final product. And so what type of manufacturing is 3D printing? We'll give you a couple seconds to think about it yourself. And so 3D printing is additive.
So you might be wondering, what is 3D printing? 3D printing is the technology that kind of builds objects layer by layer from digital models. It uses a variety of materials like plastic, metal, and resin, and it has the advantage of lowering manufacturing costs. What makes 3D printing really powerful in the medical field is its ability to produce items tailored to individual specifications, which is really important for personalized medical devices and treatment. So here's a video on how 3D printing is applied in prosthetics.
That's good. Yep. Just let me sort of control it. Yeah, good.
For amputees, sockets are a critical part of any prosthesis, supporting their weight and movement. But they often have to be modified or remade several times if the initial fit isn't right, and to adapt to the changing shape of the patient's limb, says physiatrist Dr. Amanda Mayo. It's a multi-step process, each one taking about 8 hours to complete by hand.
So prosthetics is made very manually, like we take manual casts and the prosthetists and the technicians have to do a lot of fabrication, so it takes a long time, and we're just trying to see if we can make things more efficiently for patients and use 3D printing sort of in the prosthetic space.
That's led to Sunnybrook trialing this, having a 3D printer do the work, creating a digital model of the patient's leg from a computerized scan using a handheld tablet. Sean Fitzpatrick became an amputee following a motorcycle collision last year. He says the traditional manual casting method has its drawbacks.
It's a whole week before you get it, and a whole week mightn't seem much, but for somebody that's learned how to walk and everything, it's pretty significant.
He says it would be great for patients to have another option.
So I hope 3D printing, once it scans your whole leg, that's your leg. And hope that slides on and it fits like a glove.
Dr. Mayo says there are a lot of people who are building prosthetics, but Sunnybrook is the first to study how safe, effective, and patient-friendly 3D printing is. For now, the focus is on testing the technology on patients with lower extremity limb loss. If successful, it could offer prosthetists one more tool to work with and skills around what could very well be the technology shaping the future of their field. With Sunnyview, I'm Monica Mattis.
That really shows how 3D printing can be applied in fields like prosthetics. Okay, so eNable is a really great example of how 3D printing is being applied in biomedical engineering. With 3D printed bones, different pieces are printed to act as the bones of a prosthetic. These can be customized to meet the specific needs and anatomical requirements of the user. Pins, which can be either purchased or 3D printed, are used as joints to allow for the articulation and movement of the prosthetic bone. Elastic and string mechanisms then wrap around these joints, connecting different parts of the bones to provide tension, functioning as muscles, and tendons or ligaments. A socket is designed to securely attach the prosthetic to the client's remaining limb, allowing the residual limb to engage with the tensioner strings, giving them control over the entire prosthetic. Extended bands further enhances this control and functionality, and it really improves the range of motion and dexterity that users look for. So if you look at this picture, it really highlights how tension strings are integrated into the prosthetic to give the hand control. As you can see here, these sections act as the bones of the finger, and it allows for a range of motion and functionality that closely mimics natural movement.
And so now we're going to talk about the process of product development. And so the first step in this process is an idea generation. And so this is the initial phase that usually involves brainstorming ideas for a new product or improving an existing one. And so ideas can come from market needs, technological advancements, or research insights, similar to how Purna talked about making a prosthetic. And then these concepts are developed based on feasibility and initial prototypes to determine if the idea is worth pursuing. And so that is how the idea screening is done. And then once the concept is selected, thorough research is conducted to assess its technical feasibility, market potential, regulatory any requirements there are, and then financial viability. And prototyping and proof of concept studies are also often performed to validate the concept and identify any potential challenges there might be with developing the product. And then lastly, or next is design and development. So engineers and designers collaborate and create detailed specifications and design plans based on what the concept is. And so sometimes we can use computer-aided design, otherwise known as CAD, to create virtual models and of the prototypes, which allows for iterative refinement and testing. And then after the testing and validation, there's approval, and then finally we go into manufacturing and production. And so, as I mentioned before, what is CAD? So CAD stands for Computer Aided Design. It refers to the use of computer software and systems to create, modify, and analyze and optimize designs for various purposes. So it's normally used in engineering, architecture, and manufacturing, and any other industries where precise and detailed designs are required. And so some of the key features and capabilities of CAD include 2D and 3D modeling. So CAD allows designers to create both two-dimensional drawings and three-dimensional models of parts, assemblies, and structures. The next key feature is precision and accuracy. So CAD tools enable precise measurement, alignment, and manipulation of geometric shapes and dimensions, ensuring designs meet exact specifications. The next part is parametric design. So parametric modeling in CAD allows designers to define relationships and constraints between elements of a design, and changes made to one part of the model automatically update related components, facilitating the design iteration and optimization. So the next part is visualization. So CAD software provides realistic visual representations of design, including rendering materials, textures, and lighting effects, which help stakeholders also visualize the final product. Next is collaboration and documentation. So CAD systems support the creation of detailed documentation, including drawings, annotations, bills of materials, and assembly instructions. And these documents are important for manufacturing, quality control, and so the next part and the last part is simulation and analysis. Some CAD tools include simulation analysis features to evaluate factors such as stress, thermal performance, fluid dynamics, and other motion within the design. This helps engineers optimize designs and predict behavior before physical prototypes are made.
So here's another video kind of relating to the last one we saw about how 3D printing can actually help create prosthetics a lot better.
A hand like this has many names: superhero hand, even robot hand. Faith Lennox says her friends at school think it's really cool.
They want a robot hand too.
Faith's arm was amputated when she was 9 months old. She's now almost 8.
When she was born, somehow the circulation to her left forearm got cut off, causing something called compartment syndrome.
Through an online support group, Faith's mother Nicole heard about an organization called Enable that uses 3D printers to create free prosthetic hands for children around the world. She also met Mark Langsfeld, the owner of Builded Workspace, a place that does engineering and design work. Nicole Lennox asked if Langsfeld could print her daughter a prosthetic hand.
We just looked at it as, well, it's printing a part. Why not? I mean, if it's a prosthetic hand or a bracket, it's a part.
With the help of designs and instructions from the Enable website, Langsfeld printed and assembled the device.
Wow, let's try this, see what this is, what it is all about, and also how we can help a little girl, ride a bike ultimately.
Mark Sorkeo specializes in making and fitting traditional prosthetic limbs.
3D printing versus traditional could save a lot of time, a lot of hours, a lot of manpower.
A traditional prosthesis like this one will take 1 to 2 months to make and fit, and it costs thousands of dollars. On the other hand, a 3D printed device like this one could take as little as just a few days to print and assemble, and Enable says it can cost as little as $30. The organization also makes and sends devices of different sizes overseas so local doctors can distribute them.
I believe that 3D printing will enable these people to receive prosthetic devices and also change the way that they live their lives and also change the way that they can provide for their families.
In a Skype interview, Enable's John Wong says there are also psychological benefits.
I myself was born, missing fingers, and so I was teased and bullied when I was in school. And so I know all too well, what sort of issues children go through.
Nicole Lennox says she has definitely seen a change in her daughter with her robot hand.
It's opened so many doors for her and just built so much confidence. It's really touching.
I can hold on to my bike handle and sit up nice and tall.
And if Faith outgrows or breaks a piece of her robot hand, she just has to print a new one. Elizabeth Lee for VOA News, Los Angeles.
Well done.
So this video really shows how 3D printing can help people of all ages in stuff like prosthetics. Sorry, I was muted. So 3D printing impacts is really great, and it allows for rapid prototyping, as we've seen with the second video, where the prosthetics, they're able to make the prosthetics quicker, and it's able to reach the patients quicker as well. And so this also ties into medicine, how we are able to make these prosthetics in the first place. And another cool addition is it's also involved in space design. So we've 3D printed parts to also be a part of and to make complex components for these designs as well. So benefits of 3D printing. 3D printing has a lot of benefits, making it an ideal choice for various applications. So in terms of speed, it produces parts a lot faster than traditional methods like we saw in the video. It's also cost effective, and it really allows for small batches or prototypes, and it allows for the creation of custom complex geometrics that are really difficult or even impossible to achieve with other technologies. This makes 3D printing a go-to solution when rapid production times, lower costs, or the needs for intricate shapes are priorities. And so 3D printing real-world application. So this is just a little fun example. So there's 3D printed dental implants. And so this is just an example of how 3D printing is helping advance society. So there's questions, if there are any questions.
We could probably just skip that. Yeah.
And so these are guys, feel free to check them out. This is our website, our Instagram, or email. If you have any further questions, feel free to reach out through any way.
So we have our new engineering magazine on our website. Yeah, and you should go check it out. Yep. So,
Yeah, thank you so much for listening.
Yeah, thank you so much for taking the time out of your day to come do this. I'm sorry about all the problems, but yeah, I think this presentation was very informative and interesting, and I'm glad that you came here to talk for us today.
Yeah, thank you so much.
Yeah.